Hello, my name is Dan Hansen and I'm a Technical Marketing Manager with Cisco's Data Center Product Group. This video is part of a series that's intended to show some of the unique advantages made possible by Cisco's server offering called the Unified Computing System, or the UCS for short. This video will show the advantages from a security perspective to offering a hypervisor and virtualization layer and extending our security boundaries directly to the VMs. To do this, we make use of a technology in UCS called a VM-FEX, and this is an example depiction where we extend network endpoints, cables, and adapter ports all the way through the hypervisor into the virtual machines, eliminating a virtual machine soft switching layer. By doing this, we can take a look at the security benefits that are offered in the UCS and extend this into the hypervisor. The first mode of operation for this VM-FEX is emulated, where we simply pass it through the hypervisor, both the control and the data plane, and eliminate soft switching. Next is we can have the option to go into a bypass mode where the data plane completely bypasses the hypervisor. We talk from VM to card and card to VM directly. Now, this are the termination points of a VM-FEX link from the fabric interconnect. The trick that makes this useful is we do this while allowing this bypass with a vMotion type capability. So in this example where we're going to have a pair of VMs living with bypass, to do the vMotion we bring it back into emulated mode, move the machine to the new host, and then it gets re-promoted into bypass mode. So having to do all these allows, again, the fabric interconnect endpoints and all of the disjoint and segmented layer 2 domains that we showed in the previous video, the Security 3 video. Now we can extend those into the virtualization layer. As we showed in that video, we have a forwarding boundary concept where we put VLANs, uplinks, and server interfaces, and in this case, beyond simply bare metal servers, but virtual machines into various DMZ examples. These forwarding paths are determined a priori, not packet by packet, and we establish this before we allow data to actually flow in the system. All of this is hardware enforced. So now we'll jump in and show a fundamental part of, just to kick this off from the securing the VM perspective. We'll first start with BIOS and implementing Intel virtualization technology. Now, we don't show this simply because this part is a unique UCS advantage. The unique UCS advantage is we can take all of this BIOS policy, map it into a service profile, and that makes it very easy to replicate across many servers in the infrastructure and ensure conformance. So these virtualization technologies not only allow for the hypervisor bypass, but also the protection of memory, of VM memory from the actual OS and from each other. And this is protected at a hardware layer. So in my example server here, or the service profile I'll be using, I have this BIOS policy that implemented these virtualization extensions, and I have them applied to the given server. So it makes implementation of the Intel capabilities much more easy and straightforward. Now, another one we have here is VNIC templates in our system. So we have a template, and we apply these to bare metal servers, but you'll also see the ability to apply these to virtual machines, applying all of our policies, the security policy, our quality of service, and these will then get pushed into what are called port profiles. And this is just groupings of data, of configuration, that is going to live on the network behind these VM-FEX links that are extended to the virtual machines. So in this example, you'll see some of the configuration that has been put onto these port profiles, or I could natively define them right here as opposed to using them on a template, a VNIC template. And as I come through and show the the actual VLANs that are part of these port profiles and where I'm pushing this port profile, this becomes important again from a security perspective. And this is to host multiple virtualization security domains along with bare metal on the same UCS system. So again, we have the various parameters in one of these port profiles, and the The I/O performance, high performance mode is that the hypervisor bypass that we're talking about. So in an example VMware implementation, we'll take an existing vCenter domain that we have configured out there. You'll see, we'll scroll down to these hosts. It's these bottom 3 hosts that we have here. And those are members of this single DVS that is set up for VM-FEX. All of these servers have adapters that are talking using VM-FEX technology, bypassing the hypervisor, and talking to the network. So even east to west server communication goes through the upstream switch. And while you would think that might be a performance penalty for doing so, it's actually optimized with hardware cut-through technology and other devices where we've shown in reports that it actually outperforms from both a bandwidth and latency perspective soft switching itself with the store and forward nature and frame copying that has to go on. Now, having said that, we show again the vCenter that's out there and how we've published individual port profiles to a given vCenter, and you can see how they show the actual virtual machines and the hypervisor adapters for management and live migration that exist out there on these hosts. So those all look exactly the same from the UCS perspective. I can go look at what DVS this is a member of and the VM:FEX that are being sorted. You'll see these are VMware MAC addresses that are actually put on there. Now, as an aside, we are showing this demonstration with VMware. We do the exact same capability with both KVM hypervisors and with Hyper-V hypervisors today. Now, having said that, what I'll do is bring up my host, and I will just ping this VM, which is the VM-FEX device, which is this .180 host that lives out there. And connectivity flows normally, as we would expect. And as we look at my list of hosts, I'll show that here's an adapter on there, and my direct path I/O is indeed active on this adapter that was set up in the port profile earlier for communication out into the network infrastructure. So when I take a look at that and say, okay, here it is, it's living on the host number 245, and I'm going to live migrate it. Migrate it to one of my rack mounts, actually, 237 host. And it gets moved along. So what it's doing again is going from bypass mode into emulated. It's going to move to the new host and then jump back into bypass mode. Since this is an extended link off of the fabric interconnect with all of the security domains and segmentation that are happening there, okay, the only time the actual hypervisor sees the flow is during the live migration. And after it's done, you'll see here, the status is again active, and we're running in the bypass mode. And we still have connectivity to that same server. So now what I'm doing is saying, okay, let's jump over to a new vCenter server. If the customer, if in your environment you say, I have a separate vCenter per security domain, and what we're going to show here is how to take one common UCS and connect into that alternative vCenter domain. So I'm going to say, let's just use an example of a DMZ1 vCenter device. We'll type in its IP. It's at a different host IP here. We will jump into the same folder structure that's there. I don't have a high-level folder, but within my data center, which we'll put in here, I'm going to create a folder group under there. So the first folder we'll put in is just a DMZ PTS switches. So if I want more than one living in that DMZ, and I go and add the DVS, so we'll have one for our DMZ host on this new vCenter server. And again, this is showing the example of creating a separate vCenter per security segment on the customer infrastructure. So we finish this up, and the structure is created, replicated, communication to and from the device. Now, what part I've not shown the full steps. I've taken this certificate and put it on the new vCenter device to allow communication to and from it. So all of a sudden the folder of PTS switches shows up on this new vCenter, and you'll see just the default port groups listed out there, which are for if things become isolated. So what we need to do is say, I'm going to create a port profile here, and I'll do that for the individual VLANs that I've created in the earlier security video, Security 3, and I'm going to push those same VLANs off now into the virtualized infrastructure the same as I did for the bare metal infrastructure. Assign the same network control policy, allow high performance, and even though I'm not going to pitch a pin group here, I would restrict it to links within that disjoint layer 2 network upstream. Then what I'm going to do is actually come and publish this port profile to just that vCenter. Okay, and so I go through the wizard here and pull in the right performance parameters that I want, security parameters, and you'll see that that client is now showing up. Now what I'm going to do is take this DMZ, and I've actually gone ahead and just skipped ahead. I've created 2 of the VLANs, but I'm going to take it and publish it into that DMZ vCenter now for use on those devices. And so what I've done is taken that entire data and control plane from my virtualization layer, kept them separate, talking to the UCS system, and the separation goes all the way down through the UCS infrastructure, so that on a server by server basis it can be a member of one of these 2 vCenter data centers. So you'll see I'm creating port profile clients to actually publish this on the infrastructure. So when I jump over to the original vCenter, you'll see nothing has been added there. These are the same set of networks that were already there. None of my operations that apply to my DMZ vCenter server have been affecting any of my operations on my operational, I'll say, or internal, or maybe better as another security segment in my UCS system. So we will bring up the list of hosts, and you'll see again the 3 hosts and the VMs that are living out there. And again, on this VM, we're operating in the bypass mode. But when I look at the adapters, you'll see this given networks that this VM can attach to are derived from the hosts that live within that data center, which is the VM-FEX cluster in this example. So I'll drop back into the UCS DVS. This is the internal PTS. I see the 3 hosts that are members here, and an important limit that is a benefit from a security perspective is a given server, a given hypervisor host can only live within one VM-FEX DVS. Otherwise, the vCenter administrator would have full carte blanche to go and add VM-FEX from any security domain. So on here, let's say, well, okay, I just want to show the example of creating a second DVS to be enabled within my DMZ in this case. So what I've done is created a second one, and I can then go and choose what port profiles to publish, to make available, to attach vNICs to behind that device. So on here, as we take a look and jump back, you'll see that existence with the default port groups live out on that new vCenter. So this is how I could do multiple DVSs within the vCenter infrastructure. Again, though, a host can fundamentally only belong to one, and the data center that's a member of, the VMs will be restricted to that usage of that DVS only. So on here we show my, on the UCS side, say, you know what, let's go back to our original vCenter that was out there and just quickly show the capacity to say, what if I wanted to put another DVS out there on this, and I want to treat that essentially as a separate security domain. So this is just showing an important capability, and what that is okay, I've created a separate DVS on my infrastructure, on my existing infrastructure, with a single vCenter, but it's going to have multiple security segments underneath it. So I have two DVSs, and what I can do then is show the capability on these hosts, even though these hosts are a member of the one DVS, and I'm talking again through the original DVSs, the original adapter backings that are existing, and if I choose to grow that out, again, I will just be presented with a list of options to talk within that single DVS that the host is a member of. But the added capability here is saying, well, okay, now let's say that within a single vCenter connection, I want to host multiple clusters, if you will. So this is showing the example of what a single host looked like, even when there were multiple DVSs out there. So on here, if I jump onto the console of a host, and I will actually show what it looks like from the management interface, you'll see that right now, from the UI perspective, if I look at the management network, I don't have the option to create any physical changes to the physical adapters that are defined for the management and live migration and other interfaces on the system. All of this has been pushed out onto the UCS infrastructure. So we'll just take another look. We'll jump into the local tech support mode, log in there, and if we start taking a look at the vSwitch configuration here, you'll see that there's the port group for management up top, but I have my uplinks, my physical uplinks off of the server onto the infrastructure, but I have all these DVS ports. And again, the vNICs here, all of them, Hypervisor and VM, are bypassing the Hypervisor into the infrastructure, making monitoring with tool sets on a compromised Hypervisor, while not impossible, far more difficult to accomplish. So typing, I am taking a look at the actual vNICs on the host, the VMKs, and you'll see the pair that are living out there, and the IPs. These are just the management IPs and the live migrations. But again, these are being passed through. These ones don't get passed through the Hypervisor because they're actually talking to the Hypervisor. That's not the Unix side, but we'll take a look at the PCI devices, and you'll see all the different PCI devices that actually are shown on the host. But again, I don't have the interfaces into the kernel of this Hypervisor to actually see and tap and take a look at those devices. So if I take a look at the NICs again, those are actually being presented to the Hypervisor. But when I take a look at the actual physical adapters, you'll see I see a pair, or four here actually, because I have two going into a VMware DVS, and then I have a pair going into the VM-FEX DVS. That's the max we can put into a single host. So I have those adapters configured on the system. Now we jump back into the actual vCenter, the original, and we take a look inside the networking setup there. We can see that the second DVS that we added, living out on the infrastructure, and if we take a look at the folders and how they look on the UCS side, you can see where these actual four groups of DVSs that have been created. But I can take this DMZ port profile that I defined earlier, and again, in the case where I want just a single vCenter hosting multiple security domains, I can, again, just call this the original vCenter, but put a DMZ out there, and again, this is just meant to be a series of examples. But what I can do is go into the original set of PTS switches, and this time what I'm going to do is go into the DVS that I've defined on my original vCenter and push a a segment for the DMZ actually out there. And in this case, I'm just calling it DMZ2. But again, it falls completely within the segmented layer 2 boundary. So the only way it can talk is by going completely through the UCS fabric out of the mapped uplink ports that we showed on the Security 3 video. Now I have that pushed out there, and I could take a given host, for example, move it out of the original DMZ and into this new, out of the original infrastructure, and move it into this new DMZ to have that be used. So to recap, this can be modifying or supporting multiple security domains within a UCS infrastructure is far easier and more capable than you might get with a legacy model and supporting multiple V switches or multiple DVS. By creating a robust security policy on the UCS fabrics and allowing them to simply be pushed out into the virtualized infrastructure, as opposed to moving a bunch of virtualization switching technologies and services technologies out into those layers and creating additional devices to manage. This ends this UCS Advantage video, where we show how unique capabilities in the Cisco UCS can lead to simplified deployment models with a much faster service turnaround to meet the increasing demands of the business. Please go to www.cisco.com/go/UCS for printed collateral, including a brochure that highlights the information shown in this video. Thank you.